And so we got to know Yuri over via phone, and he has a lot to share with all of us tonight. Everyone welcome Yuri Gorby from the Rensselaer Polytechnic Institute in Troy, New York. Thank you.
I could have used those last 2 minutes.
Do you want this to hold it? I'll hold it.
Sure, but can I just put this, since it'd be easier
Yes.
just to put this on, plug this in my
Sure.
computer. Great. Nice to have this.
Does everybody have a note card? If you have questions, you can write questions out on the note card. We are going to have very little time at the end to take questions, but we will take some questions, and if you have, they'll pass them out. We'll pass them out now. This is a good time. Little pencils and paper. And whatever question we don't get to answer tonight, we will write down your question and have the scientists answer them, and we will post it on our website, RadioactiveWasteAlert.org. Yes, Terry?
Are you going to put the slideshows at your website?
Yes, we are going to put the slideshows on our website. And our website is on the program. You can see it, and RadioactiveWasteAlert.org. Are you ready, Yuri?
Nearly.
Okay, great. Yuri just got here. His plane was delayed in this snowy weather, and he's been in China traveling, and didn't want to miss any more of his classes that he was teaching.
Yeah.
So
Actually, I did, but, I could miss all of them, but they would not keep me there for very long.
right.
Okay.
Okay.
Nearly.
So, anyways, so he got here, and we're so glad he did, and I'm so glad that you all are here because I think he will tie all of this great science and all this great knowledge together.
Okay, and I can start.
Okay.
Yeah, I'll do that, and I'll just keep an eye on that when something happens. Actually, can I get a little technical help? I heard that someone might be, yeah. Great, and I'll start while that begins. So I'm going to cancel out of this one, and I want to just start that one here when it comes up. Just let it run a little bit. Okay, I'll start by just introducing myself. My name is Yuri Gorby. I am a professor in the Department of Civil and Environmental Engineering in Rensselaer Polytechnic Institute in Troy, New York. I actually, if we can start that up then. I have worked, my background is in environmental microbiology and microbial physiology. I've worked in the US Geological Survey. After getting my PhD, I worked with the US Geological Survey to try to understand organisms that could do things like use uranium as an electron acceptor, that is, organisms that can actually breathe uranium. And if that comes up here, I'll show you what that looks like. And it looks like it might do it. Thank you. What timing? Wow. Yes, so, but mostly I want to say I grew up in West Virginia. I'm a West Virginia hoopie, as you can tell from this. My family was steel workers and actually gas and oil producers down in West Virginia. And now I really am a bioprocess engineer. I actually teach courses in that type of thing. So, but when I was first looking at getting into microbiology, I worked on organisms that could use things like iron as an electron acceptor. I'm just giving you a brief background so you can have a little bit of idea about why I'm interested in the topic that we're talking about today. It doesn't really show up here that well here in this, but these are organisms that could use iron as electron acceptor. They can breathe under these anaerobic conditions in the absence of oxygen, and by doing that, they can change the form of the iron into something more magnetic. In this case, on the right-hand side, you can see magnetite that accumulates at the poles of a dipole magnet. Now, when I was a postdoctoral fellow at the US Geological Survey, I discovered that these same organisms could actually use things like uranium as an electron acceptor. So on the left-hand side, you see uranium in its oxidized form. That is, it's lacking electrons. And it's quite soluble in solution, and it can migrate freely in groundwaters. And the work that we did showed that these microorganisms could actually dump electrons onto this uranium and change not its radioactivity or its metal composition, but actually change its chemistry. And so on the right-hand side, you see this black precipitate that forms at the bottom. That's uranium oxide. It's a common form found in deposits, in uranium ore deposits. It's also the most common form that you find in these shales. And so it has now come to light that microorganisms that catalyze this reaction actually are responsible for the deposition of uranium that we find in these ancient seabeds. So there was a natural accumulation of these, this radioactive or radionuclide and heavy metal. Now, uranium, we have depleted uranium, you have enriched uranium, the radioactivities are different, but I want to also remind everybody that uranium also has chemical toxicity. It binds pretty strongly to kidneys. It binds quite strongly to nephridia in fish, so fish kidneys, and can have really profound effects on water chemistry and life that lives in it. Now, with this discovery, I moved out to the Hanford Nuclear Reservation out in Richland, Washington. This is a 600 square mile facility that was responsible for the production of plutonium and the enrichment of fissionable products or fissionable isotopes for uranium. It's a huge site. At least when you're sitting out over there and looking out over this large desert area, it is bound by the Columbia River. You see that black line that goes around there? That's the Columbia River. My laboratory was about right here, right in there, and then I lived just off the site this way a little bit down these Rattlesnake Ridge, it's called. The facility was responsible for a lot of treatment of waste, and we have high-level radioactive materials there. We have these low-level mixed radioactive hazardous waste, these things that are organic or hydrocarbons mixed with low-level radioactive materials. Very problematic waste streams because it's very difficult to actually separate those metal contaminants from the organic contaminants. Very difficult to do indeed, and there are large tank farms in this place where they're storing these materials. Lots of those tanks have leaked. There's been direct disposal of low-level mixed radioactive waste into the environment. I can tell you one thing, we have very strong oversight. I worked at that place from 1991 till 2006. Just after the 2005 Energy Policy Act, which is another story. But this facility was really remarkable, but it was very tightly controlled. I mean, we had tight regulations on how we handled things, labeled things. I mean, 10 milliliters of a uranium solution like you saw in those little bottles was something that was handled with great care, and you could instantly lose your job if you didn't follow protocol. Now, that was 600 square miles. The Marcellus and Utica shale spans something like 95,000 square miles. We've been working on that place out there at the Hanford Nuclear Reservation for 50 years, 45, 50 years to try to clean it up. That place would fit into, where are we? Now this is, I can't see anything here. If I go by, the Hanford site would be a little blip on this thing. That's the expanse of what's going on right now. The amount of activity that we're talking about, and this is highly industrialized activity, as you know, far exceeds anything that I had experienced at the Hanford Nuclear Reservation. The regulation or the lack of oversight of that is something that is quite disconcerting, especially for somebody like me that had spent 15 years with 2 people on your back, making sure that you didn't spill a drop of this relatively benign materials that I work with in the lab. Now, I want to have a little brief introduction. We're going to get into drilling. Now, I'm not a driller. I don't have any background in it. I will admit that. But I have spent the last year or so contacting and becoming acquaintances with drillers, ex-drillers, lots of people in the industry, because I wanted to understand how this actually works a little bit. So I'm going to just I'm going to do something. Yeah, it is really dark. I'm sorry about the darkness, but I've used a couple of I guess I've lifted some stuff off of the internet without actually asking for. Yeah. Okay. Anyway, hopefully you've checked this out, because these are fantastic little illustrations or cartoons of the process, and that's better. So I didn't want to like chance running these movies, but if you go into any of the, you just type in, drilling technology or whatever, you'll get these beautiful things that are actually movies online. And I'll just go quickly through this. There's a nice well pad. I mean, that really is how it looks. Not. There are the technology. This goes in. This is drilling down into these formations. And here's the drill bit now doing its vertical boring, going down in here. Now, typically, we'll see this as air drilling, using these air hammers. Air hammers use air drilling. When you're doing air drilling, sometimes they'll include foams in there, or this unifoam. You'll see some of that, or what is the other one? Air foam. And that's to help plug up the formation a little bit, so you don't get all of your air going into your formation. The drill then goes down into this system. Air foam, by the way, has some nasty things like pretty strong endocrine disruptors in it, and so that's stuff that comes up out of that hole and sprays into to the air, and things that can get into groundwaters are really problematic in terms of hormone fluxes in pubescent teens. So if you're around this type of thing, this is what you want to kind of worry about during this phase. This is not fracking, right? This is just the drilling phase. Now, here's an interesting thing. The real advance in hydraulic fracturing, because we do know that hydraulic fracturing has been around for 60 or 70 years. But this technology, to be able to direct the direction, to move the direction of the bit, is something quite profound and quite new. This technology was advanced largely by one of our favorites, the Halliburton Corporation. It is a remarkable technology. The geotechnical engineers that I work with just find this fascinating, and actually so do I. To be able to do this with GPS control on this tip is just remarkable. But, however, when you start turning the bit, there's some things that you can't do air drilling anymore at this point, because that curvature then causes friction. You have to have these friction reducers. You have to start adding liquids to these systems so that you can, and I'm using liquids in a generic term, we won't get into the details of what those liquids are, but they are not benign. And then this turns into the formation. Now at this point then, drill cuttings, which are dry, typically you can get a nice drill cutting. If you go straight down vertical, you can pull up some cuttings and you can do analysis on that. But when you're moving that bit around, when you're directing the bit, the inclusion of liquids into this technology at this point generates things like drill muds, the fluids that are associated with drill cuttings, and changes the chemistry, changes the texture, changes everything about what you're dealing with. And again, this is absolutely necessary to stop that thing basically from heating up and all of this thing. You can get into the details. If you are interested in the details, I can answer that through my contacts with drillers and ex-drillers. Now, so just this, you get into this formation, and now that you have these drill cuttings coming up, and okay, so let's say that you hadn't used any of these liquids that are needed, these fluids. When you go laterally into these formations, you definitely have to include drill fluids into this. And this is not just a small distance that you have to go. This is a large length. This total depth of these wells can be 12,000, 15,000, 18,000 feet if you count the vertical depth and then the horizontal run of these bores. And that just keeps going. Now look, these are typically around 7 7/8 inch bits. The bit, and they rattle a little bit at the front, or they move around so that the holes are actually a little bit larger. Let's say 8 inch holes. And if you want to run the volume of the material, you can just do a simple calculation of the volume of a column, and you can calculate out, if you're running out half a mile in the direction, you can calculate how much material is being brought up to the surface. And remember, you have to use lots of fluids and lots of pressure to keep those drill cuttings and material coming back up that hole. So it is a really a volume intensive process. They're not shown here, and that's unfortunate that they don't include that in these descriptions. Yeah, I mean, everything looks really great here. I mean, it looks like an Italian layer cake, you know, but this is, you know, out in West Virginia we have vacancies, we have mine shafts, we have other wells that are all over the place that you can actually communicate with if you're not doing this properly, and many times things aren't done properly because of haste. Now, there are cement casings that's installed, we all know about those. And then the drill bit extends that bore even further. I mean, we're going out a long, long ways. Again, casing. And now here's where these fractures are created. Now, these perf guns, I just sat in a talk at Rensselaer Polytechnic Institute where I am, a new hire that was coming in who's an expert on uranium-tipped bullets, you know, for armor piercing and especially cement-piercing bullets. Well, that depleted uranium is used because it is a dense material. It's really hard, and it can go through steel, it can go through cement, and actually it can go through these shale formations with remarkable precision. That's how he described it to me. So a lot of the perforation is done with depleted uranium. It's also a good way to kind of get rid of some of the excess depleted uranium that we've generated during the Cold War efforts. But these things are exploded into these formations, and then of course we know that the rest of it, you know, you have to put the fluids down in there, the chemicals that are included, the biocides to kill back the sulfate-reducing bacteria that generate hydrogen sulfide. All of the chemicals that are necessary, the weighting chemicals, things like barium or barite that's used so that you can have the proper density of fluids. We won't go into any of that. We'll try to stick to the topic, which is the shale itself. Now, I think that you've probably already gone through some of this, and again, this is not my area of expertise, so I won't go through this. But there are, you know, basically measurements that one could make on these the decay series of all of these, including you know, uranium, thorium, right down through, you know, the whole series. But I'm gonna skip all that. Now, there is some information out there from the Ohio Department of Health. I just was perusing this a little bit, actually just skimming it, not perusing it, when I was coming down. And there are some measurements that it's making, and you can read through this, and I'm not going to go through this in detail. First of all, we can't hardly read it here, but I want to get to another important aspect of all this. I do want to say that there are some things that the sample analysis, they talk about how you have to grow in these different isotopes, the 21-day kind of like incubation, and I think that you might have discussed that already. I'm sorry that I missed the earlier talk on that. But this is a process that is being used, and we can look at the numbers later on. But I just want to get to something that's really probably more important from a West Virginia standpoint. I mean, you guys are getting all of our crap. I mean, you know, Ohio is accepting large volumes of waste, cuttings, muds. It's just remarkable that this is happening. But it isn't just about like drill cuttings. You have drill muds, landfill leachates, flowback, produced water, condensate, brine, all of these different materials that have interacted for different lengths of time in the formation. Emissions from well pads, emissions from compressor stations, emissions from cryogenic separation facilities. Look, Carolyn, I know you wanted me to talk about, you know, what was impacting here, but I want to do something a little bit different, just to raise again the awareness of people that live on the fringes. Thankfully, you live on the fringes of these shale plays, and you're not really in a heavily drilled area. But where I'm from, and where where I'm from, they are hammering it down there, and there are receiving lots of materials. This is a manhole cover that was accessible on a man's property because his system tied into this. This is in southwest Pennsylvania. This manhole cover led from a landfill that had received drill cuttings that were being heap leached, and there is a leachate that comes through there, and that leachate is basically free flowing down this line 4 miles downhill to a wastewater treatment facility that's taking massive amounts of this material, doing a single pass, and then dumping it into the Monongahela River. And so this, I can tell you by my background or my knowledge of bioprocess engineering related to wastewater treatment facilities, that material which made me sick absolutely upon opening it, that did have radon in the headspace over this thing. That material that was flowing down there is not something that should be coming out of a landfill that's flowing into a wastewater treatment facility. If I was the operator of that treatment facility, that thing would screw up my bioprocess absolutely, and I think that that's something that we should be aware of as we go forward. We did take some measurements of radon in there, and I won't go into the details because, I mean, this is, you know, sipping a sample out of there. It's not the standard protocol by any means, but there are standard protocols that can be, that can and should be followed. Now, we did recover some of this material, and it's undergoing both chemical and radiological analysis. I don't have the data to share with you now, but we will have this together. This material, again, you have to collect it in special bottle types, plastic for heavy metals, glass bottles, darkened glass bottles for the chemical composition and gas composition. You can do these, you know, bubbling experiments so that you remove the radon, you let it grow in, and then measure the radon content to back calculate the radium in that water. It's a whole process, and it's not a simple process. And if you want to do it properly, it takes some time. And you have to have experts that know what they're doing with it. So what I want to talk about then is all things are connected. All of this whole process, it's a massive industrial complex that it has tentacles that's spreading all over the place. Here we're depositing, you know, we're getting rid of waste. In West Virginia, they are extracting. In New York State, they are still, you know, although hydraulic fracturing, or at least high volume hydraulic fracturing is currently under a moratorium, there's discussion about the pipeline network and compressor stations and how we're going to move that gas to the shores for export, mostly to Europe. And that is part of the infrastructure. The Department of Energy is permitting previously classified import terminals, one at Lusby, Maryland, into export terminals. And when you do that, it's not just like, oh, we're going to just reverse the flow. An import terminal, you have a place that can hook up to these boats, and you just pump gas inland and you know, provide gas to New England. When you transform that into an export terminal, you have to have a liquefaction facility. In these gases that still need to be processed, they're going to need to have fractionation facilities. The 50 acre footprint of the import facilities, and now will expand to 500 acres and generate lots of secondary waste. We have to be aware of that. This is happening, and please, you know, get onto the Department of Energy website and watch the progression of the transformation of these import terminals into export terminals. It has significant implications for water quality along our coast. So this is what we see. I mean, you know, we can't really see things here so well, but we know these things, right? This is what's happening. Actually, there's something off this side. There's a spray that's going up from this this station here. There's a glycol dehydrator that's gone up and has injected material into the atmosphere. It goes up above the trees. It's cut off because I don't have the right resolution on here, but you can check it out afterwards if you're interested. Now, I just want to say that, you know, I don't know if a lot of you have traveled down into the gas regions and really seen some of these public health effects, but I have. Bloody noses, rashes, neurological disorders. When I first came back from the West Coast and I was setting up areas to go sample, I started noticing that people had a cough. I started noticing that people couldn't smell the smells that I could smell. I noticed rashes on everybody's necks in these impact zones. Anxiety and stress were out of the world. Tremors on little boys that when they go to sleep, their body will clench and then release and clench and release, and now they're on heavy neurological medications to stop these seizures. Burning eyes, coughing. Yeah, I mean, it just goes on and on. Now, you can relate this, and you can try to relate it to different types of impacts. You can try to do toxicological studies of, you know, the like direct cause and effect. But you know, if you just go down there and you just take a breath of air, or you're walking around with your 8-year-old son like I did, and he all of a sudden he says, "Papa, I don't feel so good," and you have to vacate the area, but you're leaving a family there with a 1-month-old baby, that is hard to take, I can tell you. It is traumatic to go down there, and if you do go down, don't take children down into this region, and if you have any type of respiratory problem, or you're elderly, I would suggest a full face mask, and I'm being serious. That's what I wanted to say about that. We are taking some genomic approaches to actually studying the impacts of these exposure of people in these regions. We see persistent skin infections, persistent lung infections, respiratory infections. And I worked for 5 years with the J. Craig Venter Institute, the guy that did the human genome sequence, and it's just a remarkable facility. I became accustomed to or aware of these advanced techniques for looking at DNA, and I won't go through this, but you know, I can tell you how it works, but I'm basically hooked up with with groups of scientists that have the ability to identify organisms and genes in complex systems like this. This is an infection, a persistent infection of a friend of mine. This is actually subdermal now, but she just in February had it removed. You can see the sutures there, but that thing isn't healing up. It doesn't heal at all, as a matter of fact. This is a 12-year-old boy that has an ongoing infection. It starts as a reddened area. Of the quality here, but a reddened area that will have a watery blister that will bust open, and inside there will be like a pustulating center. And we can go in there and sample that thing with little sterile swabs, send it off for genomic analysis. And what we're trying to do now is to identify the organisms that are in there, identify any genes that are related to antibiotic resistance. Perhaps we can identify the origin of these organisms. I mean, are these, first of all, bacterial or virus? Are they coming from the air around us in this compromised skin as opportunistic pathogens, or are they originating from these deep shale formations? We have gene markers to look for things like halotolerance or these halophiles, salt-loving organisms, so we can start looking for things like that. But importantly, you can develop markers. I mean, if you can find out what's in there, and you want to see how that's distributed in the environment, you can make really sensitive detectors, markers, so that it's like fingerprinting them. And then you can follow it as it spreads around in our streams and not in a concentrated area like this. Now, I'm not saying yet, until we have the data back from this, what that is. I don't mean to be...
May I have your attention, please? The time is 8:30 p.m. and the library will be closing in 30 minutes.
Perfect.
Please begin making final selections at this time. If you need to call for a ride, please do so now. Thank you. The time now is 8:30 p.m. The library will be closing in 30 minutes. Please begin making final selections at this time. If you need to call for a ride, please do so now. Thank you.
Nice. Okay, we'll just continue. The Tao of Physics by Fritjof Capra. If you're going to get a book on the way out, it's an awesome book. The infections here on the backs of these legs. This one from a worker friend of mine, an ex-driver for the industry. This one from another boy with an infection, again, that persists on his leg. This is some images that I took of an elderly woman that lives right near a road that is being sprayed with the brine, and there's lots of truck traffic in there, and she has what's diagnosed as 4 types of psoriasis, but we've sampled those things, and it directly correlated, and her whole family is impacted with not this, but similar types of things. So this all correlated with the onset of industrial activity in their quiet little home they live, and still live. And that's some of the problem. Here is in Washington County in southwest Pennsylvania, a cat that will not leave this air scrubber that's used to take out particulates and fumes in the atmosphere. This home, outside this home, is almost intolerable to walk sometimes. Inside, it's somewhat improved. The air quality is improved by these little air scrubbers. But again, that cat didn't make it. So, there are things that you can see out in the woods. Like I took my dog down last time I came down to West Virginia. I took her out, and never let her off her leash. I mean, because you just don't know what's in the streams anymore. I mean, it's so terrifying, you know, growing up, walking in the woods, you know, feeling free to swim in any creek, anywhere, and now we see things like this. I won't even comment on what it is because I don't know, but this is the type of thing that's now happening pretty routinely throughout many of the counties in West Virginia, the really heavily impacted counties. And then this is from a cryogenic separation facility in Houston, PA. It was taken a while ago. Now I think they've tripled the number of stacks in this place, and it's expanding again to export out not methane, but more the wet gases, the other gases, ethane and propane are the big ones, being taken out by rail again for further processing and export. So look, this is what it is. I am not an activist. But I am, I mean, I think that we should be active. You know, even as scientists, we can have opinions. We are allowed not only opinions, but we can state those opinions quite strongly, and with the proper funding, which is not so easy to get these days, we can actually run experiments, conduct experiments to test hypotheses. But for the public involvement, I mean, there is something that can be done. And these types of conversation that you're having here, the organization, the attendance of this community here is part of that growing awareness. Ask questions and expect, and when necessary, demand legitimate and credible answers. Not say, oh no, it's good, it's you know, everything's going to be fine, because it is obvious that things are not fine in other areas, and they will not be fine here if we go without attention to these matters. And it's just responsible, it's responsible practice for us to do this. And protect yourself, your family, and your community. And the big thing is that, remember, this is not just this community. We live in an extended community. We live in a global community that's being heavily impacted by our activities, by the continued extraction and transportation of fossilized carbon. I don't even like to use the word fossil fuel anymore. These fossilized deposits that were put down 350 million years ago, these allowed for the conditions that we see today on this planet, or we have seen in the past. The pH of the ocean is dependent upon the sequestration, that material was put down in there. Some people would believe by God, some people would believe by processes of geology and biology. But when those things went down, when that amount of carbon was put down and taken out of our atmosphere, it balanced the pH of our oceans to allow things like coral reefs. It balanced the pH of air-breathing animals so that their blood wouldn't be acidic. This is things now that are reversing rapidly because of industrialization and the continued extraction. So, 350.org, Bill McKibben, reputable scientists, Jim Hansen, those guys, listen to them because they are speaking something, and they have been for the last 30 years, that this is an important aspect of this planet. We live on a little closed ship that's flying through space, and the little gas bubble that's on the outside controls all the processes that we know down here on land and in the ocean. So be aware of that. If you want to sit in on some of my microbiology courses, or you can get, or I can suggest some reading for you too. So we live in this extended community, and so please feel free to contact me. It's ygorby@gmail.com. We are launching Doctors Without Banjos this week, really so that doctors and health professionals from outside can actually look in on Appalachia to see what's happening down in the hills and hollers of West Virginia. And we do have a good organization of medical professionals that are taking this quite seriously. The people at Southwest Pennsylvania Environmental Health Project have done some remarkable things in raising awareness and actually documenting in these case reports that will soon be coming out the relationship or the correlation between where you live and the health that has been impacted. And then Facebook, Yuri Gorby, but for some reason, I don't know, it's really difficult to find me, people say, but I mean, how many Yuri Gorbys can there be? So that's it. I think that's all for now. Yeah, that's it for now. So Thanks again, and thank you, John.